Hello students, so today's topic is the -1 trick, which is kind of important when it comes to linear equations, and this can be applied for the homogeneous system of the linear equation, and the linear equation should be of the form Ax is equal to 0. And please keep in mind, this has to, when you are applying this form, the matrix should be in the reduced row echelon form. Now let us dissect the matrix A, which looks little bit complicated. Here the bold element 1 is a pivot which indicates the leading entry in its row. So it is nothing but leading entry in its row. Okay, in its row. Okay, so what is pivot? We have already studied. So here 1 indicates the pivot. Okay, now so let's consider this as a first point. The second point will be the variables corresponding to the column with pivots are called as basic variables or pivot variable, while the columns without pivots are called as free variables. Okay, then the last point is nothing but the asterisk. The simple asterisk is nothing but it denotes the arbitrary real number. All right, arbitrary real. This is very theoretical part, guys. In order to understand this, we have to move to the problematic part. Let's move to it. The matrix looks like this. Suppose A is equal to the matrix 1 3 0 0 3 0 0 1 0 9 and 0 0 0 1 minus 4, and this matrix, suppose this matrix is already in the row reduced echelon form and it is of the form Ax is equal to 0. First and foremost thing what we have to do is we have to find the pivot and the free variable, since already it is in the reduced row echelon form. So how to find out pivot points? We already know x1 is the starting non-zero element, so x1 comes under pivot point. Then we have to do what? So let me write the numbers x1 x2 x3 x4 x5, then it will be easy. Then we are moving to the second row. So first element is 0, second element is 0, the third element is 1, so which is of the x3, so x3 comes under pivot. Then I am going to the third row, x1 x2 x3 both are 0, therefore x4 comes under pivot. The rest two elements are x2 and x5, so that comes under free variables. So let us consider x2 is equal to t and x5 is equal to s. This is the assumptions that we are going to make. Now let us write the equations of the matrix. So it is x1 plus 3 times x 3 times x3 plus 3 times x5 is equal to 0. All right, so sorry, so this should be x2, right? Yes, x2. Yes, so let me replace x2 and x5 with the t. x1 plus 3 times t plus 3 times s is equal to 0. So x1 is equal to minus 3t minus 3s. So we got the equation for x1. Similarly, we will write for other two rows. So x3 plus 9s is equal to 0. I am directly writing them. x3 is equal to minus 9s. So we got for x3. Then I am writing for x4. What is that? My x4 minus 4s is equal to 0. x4 is equal to 4s. All right, we got the equation. Now we have to write x and we have to write the matrix form for t and s. So let us write it with lambda 1 plus lambda 2. One matrix for lambda 1, one matrix for t, one more matrix for s. Now you have to check in the first equation x1 whether it has t. Yes, it has, which is minus 3. Write the coefficient of it. Then x2, it has t. Yes, 0. Then x3, it doesn't have 0. x4 doesn't have, x5 doesn't have. Then you have to check for s whether it has minus 3. Yes. Then x2, it is 1. No, sorry, it is 0. Then x3, it is minus 9. Minus 9 here. Minus 9. x4, it is 4. Right? x5 s, yes, it is has 1. So this is the final equation, and we can say that lambda 1 lambda 2 belongs to R. Now let us take one more example. The three equations are given here, which is obviously in Ax is equal to 0 form, but whether it is in reduced row echelon form, no. So first let us write the matrix form, which looks like this. Okay, now we have to find you have to reduce it to reduced row echelon form. So for that we have to apply the row operations, right? So let us change r2 changes to r2 minus 2 times r1. So A matrix will become 1 3 2 0 minus 2 minus 1 3 5 4. All right, then we will apply for the row 3, which is row 3 changes to row 3 minus 3 times r1. So what it will happen? So 1 3 2 0 minus 2 minus 1, then 0 minus 4 and 4 minus 2. All right, so let us try to make these two elements as 0. Then r3 changes to r3 minus 2 times r2. All right, so A matrix will become what? 1 3 2, 0 minus 2 minus 1, 0 0 0. All right. Second step is we have to find the pivot element, right? So pivot element is x1 x2 and free variable is x3. Okay, I'm not going to explain it briefly. You know what it is. So let us write the equation first. So x1 plus 3 times x2 plus 2 times x3 is equal to 0, and 0 x1 minus 2 times x2 minus x3 is equal to 0. 0 x1 0 x1 plus 0 x2 plus 0 x3 is equal to 0. You need not write this 0 part, you can skip it. Okay, now what we have to do is we have to write it in the you have to write for x1 and x2 first. Okay, we know a free variable is x3, right? So we know we need x1 and x2. So x1 is what? It is just that you rearrange the terms. So what is x2? X2 is nothing but it is minus half x3. Okay, so substitution is given here. Let us dive to this the last part. Let us consider x3 is equal to t, and we will apply for the equation. So x1 is equal to minus 3, that is x2, right? So we are replacing x2 with minus half x3, which is t, minus 2t. Now which is what? Minus 3 by 2t minus 2t, and you will get the answer as what? Minus half t. Okay, so that is x1. So you got the answer for x1. Now let us find x2. What is x2? X2 is equal to minus half t. Okay, and x3 is obviously 3. Okay, it is obviously t. Now we will write, since we have only t, we are writing the equation only for lambda 1 for t, right? So that is what, for x1 minus half, x2 it is minus half, x3 it is 1. Okay, so therefore lambda 1 belongs to r. So that is all. Thank you guys for watching. If you have any doubt, please comment. Thank you.